Hello everyone, my name is Kevin Crawley and I'm here today to talk to you about Stannah and application observability with Kubernetes. Now before we get started, I want to share a little bit about myself. I am a developer evangelist at Stannah, and I'm also the principal architect and SRE at Single Music, a local startup here in Nashville, Tennessee, where I live. I'm also a Docker captain, and I organize some meetups in the area. I've also organized DevOps days here in Nashville. I've been doing software engineering in some way or fashion for over 15 years now, and I have over 5 years working with Docker. Just some random hobbies of mine: endurance athletics, running, swimming, biking. I'm a sci-fi nerd. I love The Expanse, Stargate, and Firefly, even though that's kind of aging me quite a bit. I'm also I like video games. I play a lot of RPGs, and Octopath Traveler is my current favorite. You can reach me on social media at Not Sure If Kevin. It's down there in the corner of the screen, and you can reach out to me anytime, chat with me about observability, microservices, Docker, anything cloud native really. So what are we going to talk about today? Well, first we're going to cover the topic of what is observability, and then we're going to dive into how Stannah actually approaches this problem and how we tackle some of the more challenging aspects of it. We're going to do a Kubernetes demo using Stannah, and then we're going to go through some use cases and examples with my startup, Single Music, and how we use Stannah to help power our microservice platform. So what does observability mean? We hear it talked about a lot, especially in the past couple years with the rise of microservice environments, distributed application environments. They greatly increase complexity. And we have to have some way to manage that complexity. In 1961, a man by the name of Richard Coleman wrote a paper on the general theory of control systems, and he posited that a system is observable if the behavior of the entire system can be determined by only looking at its inputs and outputs. Now, in modern terms, in modern software, we can get this type of information as long as we instrument the application properly. We are emitting metrics around the key performance indicators of our service, such as memory, heap, CPU usage, throughput, and there's probably some others that you may care about in your business environment. But we also have to instrument all the communication mechanisms that our services communicate through, such as REST APIs, message buses, queues, WebSockets, gRPC. There's a lot of things out there now that enable redundant and reliable communication. However, this has come at the cost of ramping up complexity and creating very large environments in which are hard to understand. But the lesson that we want to take away from Richard Coleman is that control theory and observability is well documented, and we have a good understanding of what we're trying to achieve with it and how to go about achieving that. And what we can learn from that is that we don't need to reinvent this stuff. We can apply it to our systems as it is today with applications and services such as Stannah to help achieve those goals. So I'm sure many of you are familiar with the multiple pillars of observability, the 3 pillars. We have metrics, traces, and logs. Now, I think these are very important tenets to have in your environment if you want to achieve observability, but they alone will not give you observability. So what is observability within Stannah? I would say it's not just tooling, it's automation. It's also analytics. It's similar to how DevOps is a mindset. We're really no longer treating services like Schrodinger's cat, and we have a lot more context around the events and transactions. Now, how do we achieve those goals? Well, we include monitoring, instrumentation, structured logging and tracing, alerting, dashboards, and analytics. Because realistically, when we start putting together metrics, logging, and distributed tracing, and we intersect those three, we get observability. Now, I'm going to show you how we do that using a demo application that I found. One of the things that I enjoy doing is going out on the internet, finding microservice demos, and then bringing them into Stannah to see what they look like and to see how we instrument and how we can observe those applications operating in a real environment. So what we're going to achieve today in this demo is we're going to deploy and instrument the IBM's Game On microservice demo, and we're going to learn how Stannah deploys and monitors Kubernetes. We're also going to learn how Stannah auto-discovers our application components, and then we're going to learn how Stannah correlates front-end actions to the back-end, aggregates trace metrics, and we correlate logs and application metrics directly to application performance. Now, you can learn more about Game On Text by going to this URL and learning about the architecture, but this is sort of what it looks like. We have multiple components, and we'll talk a little bit more about these as we dive into some of the traces and some of the information we get out of Stannah by instrumenting this application. But we have some typical components, including authentication, a player server, a mediator, which is sort of a hub, and then a map server. And then all of these communicate through different mechanisms, whether it be through WebSockets, through Kafka, which is a message bus, or through REST API. Now, we also have components that talk to etcd, which gets configuration, but we're not going to dive too deep into that because those are pre-service events that happen before the service is actually instantiated. So let's get started, and we'll jump into the demo. My camera's going to go away for a moment, and I'll come back when the demo's over.